Inscribed angles. The measure of an inscribed angle is half the measure of its intercepted arc. So what this is saying is ABC is an inscribed angle. We know that because the vertex is on the circle. Arc AC is an intersected arc. That's this guy right here. This is the intersected arc. So the theorem states that the angle is equal to half of the arc. If inscribed angles of a circle intersect the same arc, then the angles are congruent. Let me show you. Angle ABC and angle ADC intercept the same arc, arc AC. So we know that the angles are congruent. This angle is congruent to this angle. An inscribed angle subtends a semicircle if and only if the angle is a right angle. So what this says is if you have an inscribed angle and it subtends a semicircle, that means this guy's a diameter. It's going to happen only if this is a right angle. In problem number 1, it says find each measure. So the measure of angle LMP, this is an inscribed angle. The inscribed angle is half of the measure of the arc. So this arc is half of 36. Half of 36 is 18. So the measure of angle LMP is equal to 18. Now the measure of arc MN, that's this guy here, is going to be twice the measure of the angle. So if I double 48, the measure of arc MN is going to be 96. And that's because 2 times 48 is 96. In problem number 2, the measure of angle GFJ. So G to F to J, that's what we're looking for. This is an inscribed angle. The inscribed angle is equal to half the arc. So the measure of angle GFJ is equal to half of 110. Here's the arc. So half of 110, and that is 55. So the measure of angle GFJ is equal to 55. All right, the next one we're looking at is arc FH. So arc FH. All right, so the measure of the angle is half of the arc. So if I have the angle HJF, and that's 36, well then I need to multiply it by 2. So the measure of arc FH is equal to 2 times the angle, and that's going to give me 72. So the measure of FH is equal to 72. In problem number 3, it's asking for x. Okay, so we're subtending a circle. And what that means is that it is a right angle. So 5x plus 8 is equal to 90. If I subtract 8 on both sides, 5x is equal to 82. If I divide both sides by 5, x is going to equal, let's see, 82 divided by 5, 16.4. The measure of angle FJH. FJH. Okay, and let's see. What else do we know? Well, we also know that FGH, both of these inscribed angles intersect the same arc. So that means these angles are congruent. So 5z is equal to 4z plus 9. If I subtract 4z on both sides, z is equal to 9. If I want to find the measure of this angle, I need to substitute in the 9. So 4 times 9 plus 9, 36 plus 9, and that gives me 45 degrees. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Angles A and C are supplementary, and remember that that means they add to 180. Angles B and D are also supplementary. Question number 5 says to find the angle measure of each quadrilateral. All right, so let's start with these two. These are our opposite angles. We know that these are supplementary. So 7y plus 11y, this is going to equal 180. And so this is 18y is equal to 180. Divide both sides by 18, and y is going to give us 10. So if I were to substitute in 10 for my y, this angle is going to give me 70 degrees. Angle T, well, 11 times 10 would give me 110. And if I substitute in the 10 for the y here, 8 times 10 plus 8, that's 88 degrees. And if I want to find the last angle, I need to add up these three and then subtract from 180. So let's see. Actually, I could just find the supplement to 88. Sorry about that. Let's do this instead. And I believe that's going to give me 92 degrees. Angle V is 92 degrees. In problem number 6, let's solve for x. So 10x plus 4x plus 12 is equal to 180. Opposite angles are supplementary. 14x is equal to, if I subtract 12 from 180, I believe that's 168. If I divide both sides by 14, x is going to give me 12. If I plug in 12 into each of my x's, let's see, 4 times 12 plus 12, 48 plus 12, that's going to give me 60 degrees for angle C. That means angle A is going to give me 120 because those are supplementary. 6 times 12 plus 3, I believe that's 72 plus 3 is 75. So that's angle B. And then the supplement of 75, that's going to give me 105. And that's going to be the measure of angle D. All right, 2 more. So I'm going to go ahead and let the opposite angles add to 180. So let's see. That's going to give me 3z minus 15 is 180. If I add 15, divide both sides by 3, z is going to give me 65. If I plug that in for z, let's see, angle J, 2 times 65 plus 2, that's going to give me what, 130, 120, 32. So the measure of angle J is 132. If I find its supplement, the measure of angle L is going to give me 48. If I plug in 65 for Z here, 65 plus 25 is going to give me 90. So the measure of angle K is 90. And also the measure of angle M is going to be 90. Because then those would be supplementary. All right, last problem. Let's set our opposite angles supplement. So 7x plus 12 is 180. 7x is equal to 168. Divide both sides by 7. X is equal to 24. All right, let's substitute that in. Let's see. 4 times 24 plus 5. And the measure of angle M is going to give me 101. Okay, so if I wanted to find the measure of angle P, that's the supplement. And so that's going to give me 79. Measure of angle N, let's see, 4 times 24 minus 10. And the measure of angle N is going to give me 86 degrees. And the last one, the measure of angle Q, will be its supplement, and that's going